Look at your arm. Right now, the skin is smooth. But you already know exactly what I am about to describe, because it has happened to you hundreds of times. A cold draft, a certain note in a song, a voice in a dark room. And within a second, your skin rises into hundreds of tiny bumps, and the hairs on your arm stand straight up. Here's the problem. It does nothing. When a cat does this, it doubles in size and becomes genuinely intimidating. When a porcupine does it, its quills rise into weapons. When a sea otter does it near a shark, its fur traps a thick layer of insulating air. When you do it, you produce a handful of nearly invisible hairs and a texture like a plucked bird. Your body is running a reflex designed for a coat you no longer have. And the strangest part is not the cold. It is the music. Because a system built to survive freezing temperatures also fires when you hear a beautiful chord, watch a crowd sing together, or listen to someone tell the truth. So why is a useless reflex still installed in every human being on Earth? And what if it is not useless at all? Let us look at the machinery, because it is smaller and stranger than most people expect. Every hair on your body grows out of a follicle. Attached to that follicle is a tiny muscle called the arrector pili. That muscle is microscopic. You have never consciously moved one, and you never will. It does not answer to you. It answers to your sympathetic nervous system, the same system that handles your fight or flight response. When that system fires, it releases a signal that makes the arrector pili contract. The muscle tugs the follicle, the hair swings upright, and the skin around its base is pulled into a small mound. Multiply that by thousands, and you get goosebumps. The technical name is piloerection, or the pilomotor reflex. There is also a wonderful older word for it, horripilation. And notice what this tells us immediately. This is not a skin event. It is a nervous system event. Your goosebumps are your autonomic nervous system becoming visible on the outside of your body. In a furry mammal, this reflex is genuinely useful, and it does at least two separate jobs. The first is heat. When fur stands upright, it traps a thicker layer of still air against the skin. Still air is an excellent insulator. The muscle contractions themselves also generate a small amount of heat, and lifting the follicles tightens the surface of the skin. For an animal wearing a dense coat, that adds up to a real temperature advantage, available instantly with no movement required. The second job is size. A threatened animal that can raise its fur becomes visibly larger without moving closer to danger. Cats do this. Dogs do this along the spine. Porcupines convert it into an actual weapon by raising their quills. So the original design makes complete sense. It is a fast, cheap, automatic response to cold and to threat. Then our lineage did something that broke it. We lost the fur. Human body hair is, compared to our relatives, almost nothing. Thin, short, and sparse across most of the body, which means the reflex kept running while the equipment it controlled disappeared. Raise the hair on a chimpanzee, and you change its thermal insulation and its apparent size. Raise the hair on a human arm, and you change essentially nothing about either. Medical researchers have been blunt about this. It is not clear how important goosebumps are for humans at all. If you could not form them, you would not necessarily have any problem regulating your temperature. That is why goosebumps became a textbook example of a vestigial trait, an evolutionary leftover, filed alongside the tailbone as a feature that survives without a job. Darwin himself noticed this. Back in 1872, he pointed to human piloerection as evidence that we share ancestry with other mammals. The behavior made no sense in us and perfect sense in them. So the standard answer became simple. Goosebumps are a ghost. The wiring stayed. The muscle stayed. The reflex kept firing into empty air. And for a long time, that was where the story ended. But that answer has a hole in it, and it is worth sitting with. Evolution does remove things. Cave animals lose their eyes. Flightless birds lose functional wings. Unused structures usually shrink, simplify, or vanish. So why is this one perfectly intact? The standard reply is that it costs almost nothing. The muscle is tiny. The nerve is already there for other reasons. Natural selection does not actively dismantle systems that are not causing harm. That is a reasonable answer, but it is also a very convenient one. And in 2020, a discovery made it look incomplete. Because it turned out the arrector pili muscle was not sitting there doing nothing. It was holding something together. Researchers at Harvard studying skin at the cellular level published their findings in the journal Cell, and the result was genuinely surprising. They found that 3 things in your skin form a single connected unit: the sympathetic nerve, the arrector pili muscle, and the stem cells of the hair follicle. The nerve does not simply pass nearby. It forms synapse-like structures directly with hair follicle stem cells, which is remarkable because that is the kind of connection you expect between neurons, not between a nerve and a stem cell in your skin. Through those connections, the nervous system regulates those stem cells using norepinephrine. And here is the critical part. The arrector pili muscle is what maintains that nerve connection. It acts as the anchor that keeps the wiring attached to the stem cells. When that signaling was removed, the hair follicle stem cells did not simply continue as normal. They dropped into deep quiescence, shutting down their cell cycle and metabolism. So the same system that produces goosebumps in the short term also drives hair follicle stem cell activation and new hair growth over the long term. Read that again because it inverts everything. Cold does 2 things through one piece of hardware. In seconds, it raises your hair. Over weeks and months, it tells your skin to grow more hair. The reflex is not a leftover sitting uselessly in your skin. It is the visible tip of a system that manages your hair follicles. There is more. More recent work looked directly at what happens in human bodies during piloerection, using different kinds of triggers. The findings pushed back on the vestigial label from another direction. Piloerection in humans does respond to decreases in skin temperature, and episodes are associated with a rise in skin temperature while they happen. Different triggers also produced different internal responses. Piloerection caused by audiovisual experiences was associated with greater sympathetic arousal, while piloerection caused by touch was associated with greater parasympathetic arousal. The conclusion was careful and important. Human piloerection is not purely vestigial, and it is not only an emotional response either. It behaves like a lexive response to environmental change, sharing functional similarity with other species. So the honest position today is uncomfortable for both sides. The original insulating function is largely gone in us. But the system is not idle, and it is not disconnected. Which brings us to the question that made you curious in the first place. Why does a song do this? Cold makes sense. Fear makes sense. Both are threats, and both belong to the sympathetic nervous system. But a chord change is not a threat. A crowd singing together is not a predator. A speech is not a drop in temperature. The most straightforward explanation is that music hijacks the alarm. Music drives arousal directly. It builds expectation, then breaks or fulfills it at a precise moment. That surge runs through the same sympathetic system that handles danger and cold. The system cannot tell the difference between a genuine emergency and an overwhelming experience, so it fires the response it has. And the response it has raises hair that is barely there. Some researchers have gone further and suggested that visible emotional piloerection may now function as a social signal, an involuntary and hard-to-fake display that says, "This is affecting me." Given how humans read each other's bodies, that is plausible. But we should be honest. That part remains an open question, and the physiological study of emotional piloerection is still a young field. So let us assemble the real answer, and notice how different it is from the simple one. Goosebumps began as a functional mammalian reflex for warmth and for looking larger. Our ancestors lost the coat that made the visible part worthwhile. The visible effect became nearly meaningless. But the underlying architecture, the nerve, the muscle, and the stem cell, remained wired together. because that architecture was doing a second job that had nothing to do with looking big or staying warm in the moment. And then the reflex was borrowed a second time, not by evolution, but by experience, by music, by awe, by fear, by memory. So you are not carrying a broken feature. You are carrying a feature whose surface expression became obsolete while its infrastructure stayed essential, and which was then recruited into your emotional life almost by accident. That is not a ghost. That is something far more interesting. A structure kept alive for a reason that has almost nothing to do with why it originally existed. And this is where goosebumps stop being a small curiosity. Evolution is often described as a designer. It is not. It is a process that inherits whatever came before and modifies it under pressure, which means bodies are not clean. They are layered. Old systems get repurposed. Structures survive for reasons that change over time. Side effects become features, and features become side effects. You are looking at that process on your own skin. A muscle too small to feel, a nerve borrowed from your alarm system, a stem cell population being managed in the background, a reflex from an animal covered in fur. And on top of all of it, a modern human getting chills from a song written last year. So why do humans get goosebumps for nothing? Because it was never actually for nothing. It was for a coat you no longer wear. And because the machinery that produced it turned out to be holding your hair follicles control system in place. So evolution had no reason to remove it, and possibly good reason to keep it. What you feel on your arm is not a malfunction. It is a message from an older body, running on hardware that quietly found a second job. So the next time a song lifts the hair on your arms, do not think of it as a useless flinch. Something very old just tried to keep you warm, and it has no idea the fur is gone.